Hello everyone. Let's discuss another Leetcode problem. And this is problem number 102. And this is a medium type problem. Although this is medium, it's not, I won't say this is one of the like that much challenging. And I like this problem because this one actually gives a very good concept about BFS tree traversal, using the data structures that are needed for BFS. And yeah, so this is a tree problem where we have to traverse the tree. And so let's go to the problem statement. So given the root of a binary tree, if you're given a root, that means you're given the binary tree, because from the root you can access the other nodes that are linked. You have to return the level order traversal of the nodes, values from left to right. That means level by level. Okay, so if you look at the example here, you see this tree has like 3 levels. One, this is level 2, right? And this is level 3. So we have to make we have to traverse it level by level and then return it. So obviously, you can just from your intuition, and if you're familiar with like breadth first search, so you already understand that probably doing a breadth first search, BFS traversal on the tree, can actually help you traverse the tree in level order. And as you see, the output is going to be list. So it's the output is going to be list of lists. Okay, so list of lists. That means for level 1, you will have a list, say like this. For level 2, you will have a list like this. And for the level 3, you have to create a list like this. And the final output is going to be list of lists. So you have 3 lists. So you make one list out of these 3. Okay, so this is your output is going to be should be look like this. Okay. So for the example 2, let's see the example 2. In the example 2, it's a tree with just one node. So that means you create a list for this level. It has only one level, right? But the output is going to be list of lists. So you have to return a list of lists, although it has only one member. Okay, so it doesn't have a second member here. And finally, you know that an empty tree is also a binary tree. So if you're given an empty tree, in that case, you have to return also an empty list. Okay. Okay, so the intuitions are like doing level order binary, like BFS will probably help us create this kind of list. Okay, so let's go and try to code this. So you see here, this is problem number 102. I'm coding it in Java, and I suggest everyone, please do code it in your own language, like own favorite language. And after coding it, we will try to analyze the uh, time complexity as well as the space complexity for this algorithm. Okay. So as you know that for doing a BFS, we will need a queue data structure, and every node has a value, integer value, and also 2 pointers, left and right. So in the queue, okay, so not like this. So let's say initially, well, let's say the output, we have to have a list of lists, initiate a list of list for where we actually will put our outputs, right? So it will be list of lists. So this is a list of lists, right? And the inside lists will be of integers, right? We say result equals to new array list. Okay, so we assigned, we created a result list of list where we'll actually save our results. Okay, and then say, okay, so next we also define a queue. Okay, let's check the, okay, let's define a queue which will be used for traversing the tree. So, you know, every time we go to a node, we have to push it into the queue, right? You know, queue is a link, queue is an interface in Java. So we have to use an implementation class. Linked list actually implements queue. So we can define a queue like this. And then first we have to check if the root is null. In that case, we have to return the result. So the result is still an empty list, right? So if the root is null, we just return an empty list. Otherwise, what we do is for a BFS, right? What we have to do is we have to initially put the root node into the queue, right? And then we have to do BFS until the queue is not empty. Okay. Yep. Okay. Now the thing is, one thing that is important, you'll see important. Okay, so before I do that, for every level, I need one list, right? I have to create a separate list for every level. So if I go back here, okay, so if I go back here, you see for every level, I need one separate list, right? Okay, so let's create that list in, so it will be list of integer. So say we call it level list. Okay, and then here is one thing. In every level, actually, what I have to do is I have to say, okay, so here is one thing. Let's say when I'm doing the BFS, suppose this is the queue. Okay, so now see the 3 will be pushed first, right? And then 3 is going to be popped, right? So 3 is going to be popped. Next, we put 9. 3 is going to be popped and put in one of the lists, right? Okay, so next, after popping 3, we have to put 9 and 20. Okay, 9 and 20. Okay, so the question said like from left to right. The output should be left to right, right? Okay, so if I want the output from left to right, we have to enqueue 20 first and 9 next. Okay, so we do that and we already have reached the next level, so we pop 9. So we create a new list for this level, right? So we create a list, 9, and once I pop 9, by that time I will be pushing the 9's children, right? So 9's children are going to be whatever it is. Suppose 900 children, say 900 children, 7, not 7, actually 2. Okay, suppose 900 children 2 or something. Okay, so if I put like this, the problem here is Okay, let's see what's the problem here is. Okay, so the problem here is oh, okay, sorry, I made a mistake here. Sorry. Yeah, sorry, the mistake I made is I drew the queue wrong. The queue is a both end open data structure, right? So 3 was pushed first, and then 3 was popped and put into the output list. Okay, done. And once 3 was popped, 9 was pushed, and then 20 was pushed, right? Okay, so the next time 9 was popped, well, it has to be put in a different list because it's in a different thing, and then 2 is going to be pushed, right? If there is a 2 here. Okay, so you have to know that next time you are actually popping 20, right? You are popping 20. And then the question is, once you are actually popping 20, you are pushing, say, 7 and 15, right? Now, these 2, 7, and 15 has to go in a separate list. It shouldn't. So you should know that every level, how many nodes are in every level, right? Otherwise, if you pop again, the queue is not empty. How do you know that the next pop is not coming here, rather it has to go into a new list, right? How do you know that? So this is how you know it. Once you are once you have pushed 3 into the uh, queue, you have to know that, okay, the size is now 1. That means I will pop once. Okay, pop once, done. And then I'll put it here. Next, once I pop 3, I'm going to put 9 and 20, right? 9 and 20. So I'm going to enqueue 9 and 20. And now I know that the size of the queue is 2, right? And then I pop twice, right? And put 9 and 20 in it, right? Now see that. So even if I have put 2 here, I just pop twice. So this is 9, I pop it, and I pop twice, and I'm done with the second list, right? Next time I just pop based on how many are there in that level class. So this is important. We have to keep a count of at this point, what is the size of the queue. I just pop that many items and put it in the list. Okay, and the rest of the items that are getting also enqueued, I will take care of them later. Okay, so that's a very important thing. Okay, so if you haven't understood it yet, please try to just think about it and discuss among your friends. Make it very clear. Like, try to have a very clear conception about this thing. So so for that, what I have to do is int qlen equals to q dot size. I need to know what is the current size of the queue, and I will pop only that many times. So int I equals to 0, I less than qlen I plus plus. Okay, so every time I will pop a node. This is q dot, not pop actually, dequeue. I will dequeue a node, which is done by q dot poll. And then let's do this thing. I have to put it in a list, right? So array list, or say, oh, okay. So I already have created this, right? Level list. So I add these dequeued node into my level list. So I'm building the list for the level, right? Queue, so node dot value, and I have to add its children to the queue, right? So if node dot, I have to add the right child first to make sure that the output is from left to right. I showed you just when I was showing you in the example, right? If node dot right not equals to null, then I have to do this queue dot offer. I have to put this into the queue. Similarly, if the left node is still not null, then I also put it into the queue. Okay. Okay. So this is like, so you see that at the beginning, when I just had put the root, the queue length was 1. So I would just run this once, dequeue it 3, add it to the level list, right? And then I will add its children, that means 20 and 9 into the queue. Okay, so next time when I come back, 9 and 20 is in the queue, and the size of the queue is going to be 2. So in the next level list, only 2 items. So this is going to run for 2 times, and only 2 items are going to be added. You see that meanwhile, other things are going to be added to the queue, but those things are not going to pop in the next iteration, right? Okay. And once this is done, what I have to do is I have to add this level, because I'm done with this level. So I have to add this level list into my result list of list, right? Okay. So initially it will be added to the index 0 of this list of list. The next one will be added to the index 1. Okay, so next, so finally, once all the levels are done, the queue is going to be empty, and I'm going to return this. Okay. Okay, let's see if it passes the test cases. Okay, there's something. Oh, okay, so this is the queue of tree node, right? Okay, sorry. I have to check. I just put one. Hmm. Oh, okay. So it looks like I have to do it from left to right. So I had put sorry. Oh, okay. Q is first in, first out. You see that I made a mistake here. So if I want to put 9 before 20, I have to put in Q9 before 20. So it's first in, first out. So you see one of the things of like properties of Q, I missed it. So it was, okay, now it's accepted, and then I'm submitting. Okay. So this beats almost 89%. Okay, so there goes my code. Try to understand it. If you need more help, there is some you see discussions here. And try to read the discussions that have that highest number of votes or something. And also it has the solutions. So you can just get your own solution and sort by most votes, right? C and Java solution, C++, there are Python solution, etc. So let's talk about the time complexity. So we are doing BFS, right? So if we are doing BFS, you see BFS, we are visiting every node just once. So time complexity is order of number of vertices, right? So this is the time complexity, or you can say order of n, where n is the number of vertices. Space complexity, how much extra space we are using. So this is the extra space you see. This is the extra space, right? We are actually putting everything here in the result. And what is the final size of this list? It will be the size of this nodes, right? Because every node is occupying a space in this result list. So the space complexity is also going to be order of number of vertices. That is the extra space we'll be using to store the results. Okay. So that's it. Thank you very much for watching, and try to discuss this with your friends, and also think about it yourself. It's going to be a very good practice to understand a problem, as well as understanding this BFS traversal and using of Q data structure.